So Christopher is also one of the admins of our Slack team. You can get to that by going to atds.space, and then we have a link to join the Slack channel, Slack team on there. And so take it away. You got your slides up there. I'll grab these.
Hi, everyone. My name is Chris Agostino. I'm going to be talking today about creativity and artificial intelligence and how we can kind of subvert expectations to make LLMs and language models like think more outside the box.
Yeah, the arrows are not helpful.
Okay.
Scrolling is good.
Okay.
Finger scrolling.
Okay.
Perfect. Hopefully that's okay.
Yeah. You'll just get the drop down effect every time.
Yeah, yeah.
So to give a little bit of background about me and where I come from, so I went to UC Berkeley for undergrad, where I studied physics and astrophysics and did research in micromagnetics materials at Lawrence Berkeley Lab, and also in Kepler stars, looking at star spot evolution and modeling to try and understand if we have, or if stars are more commonly differentially rotating, or if their spots are evolving on short or longer timescales. After finishing undergrad, I went to Indiana University, where I did a PhD focused on understanding the observational diversity of active galactic nuclei, and bridging a lot of the optical and X-ray data sets together to get a more comprehensive view of the available signatures for AGNs. After or near the end of my PhD, I started feeling that I should kind of move towards, or I started getting more interested in like natural intelligence and in cognitive science. And I wanted to try and get towards a place where I can start doing like real proper AI research. Instead of trying to waste, like a year applying for a bunch of these like AI research jobs, I was like just trying to get something. So I was able to get a job at a startup doing blockchain analytics, where I learned a lot of fundamentals on AWS and PySpark and graph and network algorithms, which I was hoping to use with like machine learning models and things like that. And then after about a year there, when a lot of these new open large language models started coming out, I was doing some tests and I wanted to try and include them more in some of my work and that we were doing. But I was finding a lot that the team wasn't really interested in expanding these capabilities because they were mostly underwater anyway. So I was thinking it's probably a good time to get out. So I got out and was able to join HubSpot, where I did a lot on developing generative AI tools for the people analytics team that I was part of. So it was a team of about 10 to 15 analysts and scientists, most of whom don't really have much like proper software engineering backgrounds. Most of them were still using R or a mix of R and Python, and just we're facing a lot of friction with kind of the rise in generative AI and being told to incorporate it more in some of their work with not really being able to actually do it. And so I was able to kind of bridge that gap and build adapters for them. And so they were able to do this work more effectively on a lot of their analytics. Early last year, I decided to, or a few years ago, I formed this company, NPC Worldwide, as a kind of way to do consulting if I were able to. But then I decided to just go and do it full time. As part of that, I've been building a lot of open source AI tools. So NPC Pi is this Python package I've been developing for about a year and a half now. And I'm trying to make it kind of like the NumPy for AI and like LLMs. So it's more like of a functional procedure and less focused on all these like weird abstractions that I feel like a lot of these agent frameworks come with. Um, and I know Joseph in the last talk mentioned about how if you want to join AI or want to do ML and things, you don't have to become an ML researcher and publish papers on these things. But I want to say like you also can do that if that's what you want to do, So I was able to start like working on some papers and start submitting them to various AI conferences. And was able to submit last August at the Quantum NLP and AI conference in Bloomington, Indiana, and then in NeurUps in 2025 or in like a month ago. And a lot of what I'll be talking about today comes from that NeurUps work, but yeah. The other project I've been mainly working on as a way to try and eventually make more money is this Solaria. It's agent operations platform. It's kind of like a agentic data cloud to make more or to help businesses make agents and more collaboratively so they can work as a team together in this platform. Uh, so some of the problems that I'm going to highlight for the motivation for some of this research. So if you ask a large language model to come up with a joke or to give you a random number, it's usually going to be the same random number. So this guy did this experiment, and with GPT-4, it was, 55% of the random numbers between 0 and 10 are 7, which isn't random, likely. But the way that these models have been fine-tuned through reinforcement learning and instruction tuning results in a convergence into a kind of hive mind of responses for typical things, which I'm sure most of you have noticed. And another experiment along this vein comes from Doshi and Hauser in 2024, where they asked people to write stories using an AI model. And they found that each of the individual stories was more individually creative, but that when you compared all of them, they were more similar than if the humans had written them individually. And just want to read this from their abstract. So this dynamic resembles a social dilemma. With generative AI, writers are individually better off, but collectively a narrower scope of novel content is produced. Our results have implications for researchers, policy makers, and practitioners interested in bolstering creativity. So if you're someone who's trying to use more creativity in your work or trying to get more creativity out of these tools, it seems clear that they're not really going to be that well fit for it because they only know what they know. Um, from a recent or a few years ago now, this team looked at how we even, sorry. So this team is composed of these people who are focused on science of science, and they're looking at kind of what really matters or what is kind of the best approach to research in general. Because a lot of what we traditionally think of as kind of pushing the boundaries of research are either that you have some freak observation that motivates a new theory, or you have some theory that's built upon that people make new analogies for or new extensions of, and then they're able to get to some result. And what this team did was simulate kind of using theory-based approaches versus just random approaches, so just random starting points. And what they find is that these theory-driven strategies lead to these illusions of epistemic success, which I think is a really fun phrase. And that in contrast, the random exploration actually more uniquely balances this diversity and representativeness of the truth. So I'm sure a lot of you already know some of this, but I want to give a quick overview of how LLM sampling actually works, so that you can understand kind of where I'm going with this. So when a large language model is outputting tokens, it has the next set of available tokens, all with their probabilities set based on the training data that they have. And there are kind of three main ways that people can vary the way that this sampler outputs results. And the reason that they come up with this in the first place is because if you don't if you just go with the best option every time, it sounds very robotic, or it ends up in these loops that like never end. Um, and so the three main like parameters that people use to kind of try to tune these outputs and see like how things vary are the temperature, the top K, and the top P. So the temperature is kind of the confidence in the logit, so it like smooths or like flattens or heightens the distribution depending on which way you go. The top K like just sets the number of possible tokens to sample from in this case, and the top P sets like what are the probabilities that you want to get to before you start sampling. And I have an Italian AI agent that I've been building to test a lot of these things that I've been doing just as like a fun interface for myself and for my friends. And I asked it to come up with a graphic for this, and this is what it decided to make. And it's not, I mean, it's somewhat informative, I think, but I thought it was cute, and it put a Sicilian sunset in the background. So um, I just wanted to add that. Um, so temperature is usually like the main knob that people are tuning when they want trying to increase or decrease the creativity of these models. But there's this work, I think, from 2024 by Peepercorn, where they look at this kind of systematically and show that, you know, these temperature increases increase novelty, but they don't really actually increase creativity. Um, and so I think it's important to kind of address like what is creativity versus novelty. And you know, there are many different paths to go from any problem to any solution. You know, it might take a very direct one. It might be very roundabout. There are all these different scenarios, and you can't really know them a priori. But um, the difference kind of between what makes a solution novel versus just, or sorry, what makes a answer like a novel solution or like a creative solution is really that it is both original and valuable. So it has to be able to accomplish something in this regard. Um, and so, how exactly do humans do creativity? We are, I mean, still an open subject, but if we can kind of understand how we do it, we might be able to build a way that large language models can do it a little bit better. Um, and the typical view is that there are kind of these two main like systems and networks for the human brain, like the default mode network, so kind of like your passive processing network, and then the central executive network where you're, you know, actively thinking about something and like actively using your cognition. And what we tend to find is that when we're doing creative tasks, like these tend to both be occurring at the same time, or like both be active. Um, in the 60s, Guilford called this like divergent versus convergent thinking. Um, and he came up with this kind of alternative use test for measuring creativity in people. So like the kind of test where it's, you know, you show someone a paperclip and you ask them like, what can you build with this? Like, what are the other uses for this? Um, so ultimately what I kind of want to get to is like, if the brain is oscillating between these kind of wild generation and careful selection modes in which we're just like bubbling up random thoughts, um, and then like kind of filtering them down to like what is relevant to our given situation, then why haven't we like really tried to do the same thing with LMs? And so I developed this daydreaming and like mind wandering algorithm for LLMs, which if you've seen the movie Everything Everywhere All at Once, I've kind of just like codified that, like the way that they jump between verses. But the basic idea is you have some problem, you start off with some thoughts, and then just switch the temperature really high, and then let it go for however long it wants, and then introduce some stochastic interruption, sample the random set of tokens, and then force it to come up with a reason why these are connected to the original problem. So most of the time, these are, you know, kind of nonsense and unrelated. But some of the time, or like as a researcher is potentially using this, they can quickly evaluate, like which ones are junk versus which ones are kind of just possibly actual novel inventions. So I have this example test for a few different problems. So focusing on like primordial supermassive black hole formation, one of the answers gave cosmic livestock accretion. So supermassive black holes formed by foraging for pop 3 stars. It's not a very useful thing, but it's kind of funny. And it's, I think, important to think about how like things like this could inspire ideas in the researchers who are like interfacing with this kind of tool. And while this process kind of addresses this divergent convergent combination, it's like not necessarily the only way forward. So I had this on a previous slide, but one of the other results from these science of science experiments is that the onsets of Occam's razor that everything should be as simple as possible isn't always necessarily the best approach to science. It might be limiting us in kind of our solution finding. And one of the if we were able to kind of train a model to be like able to produce this divergent text without necessarily adjusting these samplers, we would be able to kind of have another way to produce, like have this source of divergence. And one kind of long understood source of like divergence is, dreams. So dreams are these kind of fantastical experiences that we have, and some have even purported that they are responsible for helping us to prevent overfitting in our brains. So, they introduce all these random kind of combinations of things. And so I don't know if any of you have read Finnegan's Wake by James Joyce, but it's this his final work, and it's a very experimental work where he tries to kind of simulate what happens during a dream. So characters morph shapes all the time. The sentences are complete nonsense, as you can see over here. Everything is a pun. It's very just like kind of out of left field all the time. So what I did was I both implemented a foundational model that is just able to output text like this. And then I fine-tuned an instruction model so that it is able to also answer questions for you. So just show you an example of what happens when I ask it to tell me a joke. And it says, why did the purple vulture drink the second glass of milk? Because he was a bold little loop, a flavor is isolate of humor gone stale in the mash. So it's I tried to look that up. I couldn't find anything related to a purple vulture drinking a second glass of milk. So I think it's fun. And you can kind of see like where these models line up in comparison to these kind of convergently trained, like publicly available open models, like Llama 3.2 and Qwen 3. Like the foundational model is just kind of I wouldn't say off the chart because I made the chart, but if you had made the chart originally and then plotted them, they would have kind of been off the chart. The instruction tune is a little bit closer because it's based on the Gemma 3 1 billion model, but we didn't as harshly force it to only, I don't know, it's better at some of these actual tasks, and it can get about 50% of questions right on like these minimal baseline tests. So it can still answer questions and get some of them right. So just another way to kind of provide this as a source of divergence in your kind of multi-agent systems for other agents to probe these to get random ideas, or if you're a researcher and you want to come up with new ideas. And another application I have for kind of these sources of divergence is in the evolution and cultivation of knowledge graphs. So thinking about knowledge graphs as a collection of facts or concepts, and then being able to evolve them over time, and then undergo different kind of phases, like waking, assimilation phase, where you're just adding facts and concepts, and then like a sleeping phase where you're consolidating them, and then a dreaming phase where obviously we would try to come up with new connections between facts and concepts and things together, and by introducing some of this kind of divergence. Um, so uh, that is all for me, but thank you.
Thanks. This is super interesting. So as you probably know, one of the biggest changes with LLMs last year or two has been on thinking algorithms. So an LLM, given a prompt, it then produces a bunch of tokens that it doesn't show to the user, but it's been shown in certain cases, mostly mathematics and science, that those hidden tokens are a way of its sort of internal thinking before it outputs the answer.
Yeah.
Right? And this is done by training these models in the sort of final step, I think the reinforcement learning step, to kind of think about these particular problems. And it seems like that really naturally kind of goes with your idea.
Yeah.
I mean, like, my mind is exploding thinking about this, but like, it'd be super cool if you could have, in the process of an LLM producing the answer, be it a story, joke, or whatever, it just randomly starts. Maybe we don't call it thinking tokens, we could call them hallucinating or, I don't know, dreaming tokens or something.
Daydreaming. Yeah.
Would require like some good training data. Like probably a little more sophisticated than just putting his weight and whatnot.
Yeah.
It also requires some money.
Yeah.
I know, but I mean, I'm sure have you thought about this? Like, what?
Yeah. I mean, it is my intention to like make it as like a thinking option or like a thing to do in the middle of their response. So like in the Italian AI agent that I have, it can do like this mind wandering, and so like as part of its process, it can respond with that and like use it as it's going. So that's my intention, and I'm gonna make like a reasoning model that uses this like Tiny Tim as the reasoner and then like outputs normally. So
I have a second question that I can ask off.
yeah.
Let's
Sorry.
Kristen.
All right, our next speaker up is an old friend of ATDS. Where is my picture? There it is. Okay. Kill that one. An old friend of ATDS, Taka Tanaka, who has spoken at every ATDS, I believe. So he holds the record. And so, Taka, if you want to go ahead and share your screen and go start us up.
Yeah, let me do that.
Should be able to take it over. All right.
Do you folks see my screen?
Yes, looks good from our side. So take it away.
All right, thank you. Thank you for having me once again. I'm Taka. I've been a part of the ATDS community for, I guess, since the beginning. And thank you so much to Jeff and the other organizers for having me once again. Today I wanted to share with you this new project of mine. It's called House IQ. It's an AI native real estate platform. I'll talk a lot about what that means. I'm the Chief Data and AI Officer at House IQ, and there's my contact information at the bottom if you need to get in touch with me. And as is customary at ATDS meetings, I wanted to share what my journey has been. I was in astrophysics. That was my first like real career. I got my degree in 2011, and then I spent 3 years in Munich. I worked with Rashid Snayev, and then I had a joint appointment as a research faculty member at NYU and Stony Brook. And the truth is, I just got burned out. I got tired of looking for academic jobs, and I decided, like many other people, to transition into an industry role. In industry, I was a data scientist at a consulting company. I worked with a lot of big media companies. I leaned into management. I became a team lead at Weight Watchers, and then the pandemic happened. And I wasn't affected by layoffs, but I kind of saw that the company was in a very precarious position. And then serendipitously, I made a connection at an international mobile fiction startup where I was hired to lead their data science team. Since 2021, I've been working at a real estate loans company called Rock 360. I've been heading the data and AI department there. And then since last June, we started a sister company called House IQ, where I've been the chief AI officer. My basic journey has been, I even as a physicist, I considered myself a problem solver. Um, Anytime I sat on an academic talk about, say, a colloquium or seminar about a certain astrophysics problem, I would start thinking about, okay, how would you measure this? Where's the data coming from? What are the bottlenecks in that data? What are the obvious solutions? What are the places where things might get tricky? And I'd kind of start mapping out as I was listening how I might solve that problem or how one might solve it in different ways. And that kind of mental exercise lends itself very well to corporate strategy. If you're sitting in a boardroom hearing a business problem and you can come up with a mathematical or data science or an AI solution to that business problem on the spot, you're going to have a lot of people's ears. And so that's been my career in a nutshell. Um, some of you may know the GitHub slides that I maintain. Um, it's called Astronomy to Data Science. You can Google it. It's just a set of slides that I update roughly once a year, just with general advice about how to think about data science careers, data science roles, how to think about interviewing. Yeah, and I'm happy, I'd be very happy if folks continued utilizing that tool. So, why did I decide that I wanted to be a part of House IQ? I already had a leadership executive role at a different company. Why have two executive roles? Why would I want to torture myself like that? Um, and this was something that I think the more I thought about it, the more interesting it became. And zooming out, I think if you've ever had to rent an apartment or think about buying a home or think about selling a home, I think most people would agree that real estate is just a mediocre experience for the consumer. It's a manual process. The process is very opaque. For first-time home buyers, the process can be overwhelming and confusing. If you are at a closing for a home, you're literally signing and initialing hundreds of pages of paperwork. It's just a very difficult process. And how many of you have ever read your lease front to back? That by itself is just an annoying process, and it's hard to find information. And I think now that more and more platforms and real estate agents are going to be using generative AI, I predict that this might even become harder because of all the proliferation of AI slop. I'd also argue that in real estate, the leading tools and platforms feel a little closer to the year 2016 than the year 2026. I think the predominant method is still filter-driven web search. There's lack of personalization, and the tools work. But I think if you're like me, as you're searching for properties, you're also going to just open a lot of other Google tabs to help you along the way. So real estate and the term technological efficiency, I don't think have really gone together historically. And I think that's kind of obvious if you think about real estate data in general. When you think about real estate, like who owns this property, what does it look like, what's the address, all of that is essentially analog information. It's different from if you run like an e-commerce platform or a streaming platform or social media, where you can log everything on your app. In real estate, the source of truth is a signed paper document that has to be digitized and scanned. The data is unstandardized. My apartment has a different address on the deed than on my post box, than on my electricity bills. There's 3 different addresses for my apartment. And how would you possibly know that unless you lived where I live? So data is fragmented. It's especially in the face of like the lack of address standardization. It's really difficult to join a certain address that you might find on a listing with another address that you think is the same address that's in, say, let's say government public record data. It's just when data is like that, you just can't do very simple things with data. In this respect, generative AI is a game changer because you can actually get use out of unstructured data. That's where LLMs and multimodal models thrive. That being said, there is a real lack of AI native software. I'd say like everything is a chat box. I'd say that 99% of AI we see out in the wild fall into one of 2 categories. The first is essentially a chat box that's been duct taped onto a pre-existing UI. You might see a sparkle icon, but it's essentially the same thing with a chat box attached. Another mode, I think, is you have platform access, but it's trapped inside ChatGPT. So now you can shop on Etsy through ChatGPT, but that platform is essentially locked inside ChatGPT, and you're doing everything through that chat box. And the fact is that there isn't a lot of what I'd call AI native software that's consumer using. There's a lot of AI that's happening on the back end. There's a lot of generative AI being used to optimize corporate workflows, but everything that you and I as the consumer see are essentially chat boxes. So we want to change that. The vision of House IQ is that, we want to help people find a home. We want to help people love their home. So every home journey should feel personal, informed, and you should be full of possibility. And our mission is to enable home seekers, buyers, and owners to take control of their journey through thoughtful technology that empowers more confident decisions. Right? And notice the words AI just don't show up here. Our thinking is that, right, there shouldn't be slop, there shouldn't be hype. We shouldn't be selling a product because it has AI in it. AI should be a part of the functionality of the product, and it should only be used if it's actually doing something meaningful. So let me share some platform capabilities. We have AI-powered search. It incorporates images and text. So you can do something like, hey, find me houses that have a modern interior and floor-to-ceiling windows in this city, and it'll do that. It'll actually do the abstract matching using language and images, and essentially find you the floor-to-ceiling window homes. You can reference neighborhood knowledge. So it's like, hey, I like Bushwick, but I'd like to be closer to the queue line. Or hey, I like the vibes of Bushwick, but I'm moving to Dallas. What's a neighborhood that I might like? And the vision here is that you have comprehensive, informative, intuitive, personalized. We shouldn't even have to tell you that it's AI. It should just work, and it should just work better because we're utilizing better data technology. So here's a couple of videos of our kind of InDesign flow. So right here, if a user is looking for a home, they might be able to do that in a search, and then it will pop up the results, and you should be able to scroll through on a map in an interactive way. This is kind of like an advertisement mock-up that we said we spun up. Hey, I'm looking for a place. I want to avoid the E train. Hey, this is what I'm going to search for you. And so this is just something our design team came up with. But yeah, we're envisioning something that is made better by LLMs and feels a little more now a little more the future instead of just clicking filters on a website. One of our other feature sets is around a paperwork assistant. So if you wanted to say, like I mentioned, closing on a home requires many, many documents. Even the process of applying for mortgages or submitting purchase applications or even filling out paperwork at open houses, you just end up with stacks of papers everywhere or stacks of PDFs everywhere. So you can have a tool that says, hey, look at all these documents. Tell me what I'm missing that I should have and show me any inconsistencies. Like, let me know if my mortgage isn't going to be enough to buy this house. It can do compliance checks, so it automatically references local laws and spots unusual and potentially illegal clauses. And the vision here is, right, demystify, inform, explain, contextualize. It should feel like, oh, I have a bunch of questions, or I don't know what's going to happen next as I'm looking for, right? Or if I'm parsing through a lease, or if I'm trying to find a new place to live. You shouldn't have to open a bunch of Google tabs and searches. You should be able to ask House IQ. Here's some design pages of what we're building. There might be some walkthroughs and say, hey, here's some critical alerts, like there's a clause that's critical that's missing in this purchase contract, or hey, here's some ways that we can help you understand the lingo around homes and home purchases. We have a generative AI renovation assistant. So you can visualize a room. You can show me, say, ask the AI, hey, show me what this looks like reimagined in a different way. You can do cost analysis, say, hey, you just showed me a lot of renovations I could do. What do I need to get to the end state? And then tell me roughly how much it's going to cost. So I renovated my bathroom last year and it was ended up being kind of a nightmare. And I think if you talk to anyone that's done like a remodeling or a renovation, like there's not a lot of technology out there to help you. And the process can be really frustrating and confusing, and you need to do a ton of research on your own. So again, here, this is where we think that technology can be a helpful asset. And here's some mock screens where you start with a house. The AI suggests some things that you can do with the space, and then visualize it for you and tell you how much it's going to cost, how long it's going to take, and so on. And we also have a causal inference pricing model. So it's built on Bayesian statistics, Gaussian processes, and a causal graph representation of model features. So it's a fairly involved, this is not your uncle's XGBoost model. It's a fairly involved and novel model. We actually wrote a paper on it last month. So this is a very novel inference model. And then we also have MCP servers so that people can interact with the model. So you can say, hey, why is this property worth less or more than its neighbor? So the vision here is an ML model that can answer why. And then basically a quantitative thought partner to your home search. So as you're looking at listings, you can ask, hey, is this a good deal? Or hey, why is this home priced the way it is? So on. So yeah, we've grown quite rapidly. We have a team of about 41 people. That, for full-time people, it's 30. We have 26 engineers, 20 AI engineers, so half the company is AI engineers. We have designers, product managers, and then we also have a team of go-to-market experts. So we have executive advisors, people who used to run various functions at large companies, advising us on marketing, advising us on kind of corporate strategy and building up the brand. And then as we launch our go-to-market operations, we're going to have additional marketing folks, a lot of people on the ground in the cities that we're going to be launching. This is a rough timeline of where we've been so far. Our company started operations on June 23rd, so 6.5-ish months ago. Our our in-person office opened in Chelsea in August, and then we've been growing, we've been hiring, we've been building a lot. Um, and later this month, we're going to have a private beta release of our app and our web app. And then sometime in the spring or early summer, we're aiming to do a public beta launch in select cities. So it's been a really, really rapid ramp up. And here are the things, earlier I asked, well, why the heck would I do this? Why the heck would I want to do all of this extra work? And there's a few things that I've found to be really fun while doing this. And one is just building a product that uses AI that I can take seriously. I'm a huge AI skeptic in my personal life. I probably use AI like once a month. I write my own emails. I hate AI just in my personal life. But I do believe that the technology is useful. I built a lot of AI products in my various roles that actually I believe are delivering measurable business value. So I'm really excited to bring that to the consumer and saying, hey, here's the actual things where AI can do well and AI can do faster and AI can make your life easier. And I think real estate being such a pain in the ass experience as it is, I think it's a low-hanging fruit. It gives me an opportunity to really think deliberately about safety and privacy and utility. Um, you know, Preventing hallucinations, ways to check against hallucinations, ways to check against people using the chatbot in an inappropriate way. It's a ton of things to think about, and it's also fun to think about. And imagining a new kind of software, right? You know, Instead of having a chat box, having buttons that pop up in response to what you're typing, having filters that auto update based on what you're typing and what your interactions are. Um, there's this mix of buttons and displays and LLM and multimodal AI technology. Again, I don't think that kind of experience quite exists out in the wild. That's like a default or even like a common pattern yet. So building these things, like solving for latency, solving for how to distribute the work, how to make everything run fast and where we can make things faster so you're not sitting 15 seconds for the chat box to interact with you and respond to you with every little thing you want to do. Um, and the fourth thing is it's been really fun building a company from the ground up, focusing on the culture, picking the office space. That part of it is I wouldn't trade for anything else. So yeah, stay tuned. We're looking to reimagine home searching and helping you love your home. We're also, in that process, imagining what AI native applications look like. No hype, no slop. People should use it because it's good, not because it has AI. We're launching in 3 different metro areas: the Research Triangle in North Carolina, in the Columbus, Ohio area, as well as in Minneapolis. That might happen at the same time. That might happen in a staggered stage, but by the end of the year, I want this to be national. So yeah, if you're excited about our product, or if you like tinkering with AI stuff, or if you like building software, or if you are just an incessant data hound, or if you're really into marketing, then we should talk. So yeah, that's all I have. Thank you.
Yeah, time for some questions for Taka. I'm going to start. I'm going to pull the host card and ask you, Taka, especially about as someone who has bought a house a couple of times and gone through as much as I could of those hundreds of pages of paperwork. How do you think about protecting the home buyer and your company when you're giving advice on what amounts to legal matters, right? When you're talking about clauses in contracts, especially you mentioned localized, whether it's state or county laws. So how do you think about the protections there?
Yeah. We definitely want to put front and center that we're not dispensing legal advice. We are finding information, we are sourcing the information so that the user said we show the user, hey, there's a North Carolina, right, a nonprofit that has these kind of rates for tenants, and this part of the lease seems to kind of run counter to one of the things. So ask your agent about that. Ask a lawyer about that. Um, this purchase contract is missing a clause that's frequently included. Ask your real estate agent about that. Ask your lawyer about that. So yeah, we're not, we're very clear in saying that this is not legal advice, but we also want to be helpful. And I think that I would argue it's the same kind of level that Google AI or ChatGPT is playing with. You know, no one is saying that ChatGPT is a lawyer, but people are asking it legal questions every minute of every day.
Makes sense. Thank you. Other questions for Taka?
Hi, Taka. I just have a really specific question about the AI-powered search.
Mhm.
I'm thinking about, okay, I haven't owned homes, but I rented a lot, and I do use the filters a lot. And it does take a lot of time, and I totally get what you mean by it being 2016. It takes a lot longer to basically create your own query.
Mhm.
And it sounds like what you're trying to do is create this more natural interface. But my immediate reaction to why I think I might want to stay with the filters, and unless I don't understand what you're doing well, is that when you create a filter-based query, you're going to have a high recall query. You're going to get every house within a certain geo area that has 3+ rooms, that has, et cetera, et cetera, et cetera. But if with your, in my head, if I were thinking if I were to build something like what you are building just based off natural language and images, I imagine you could probably get a high precision kind of search tool, but you inevitably I'd be worried about leaving out houses that actually match the query. Is that something that you worry about, or maybe that's just not the search mode? If someone's using natural language, maybe they don't care about that. I don't know. How do you think about that?
Not particularly. So the way it works is there are filter
Taka,
settings.
sorry, I can't hear you very well. I think when you have your hand on your.
Oh, sorry.
Thank you.
How's that? Is that
Yeah,
better?
better.
Yeah, sorry, I don't use headphones often. So the way we're envisioning this and the way we're building this is there is a set of filters that's intertwined with the chat experience. So as you're telling the chatbot, for instance, that, hey, here's what I'm looking for. I'm looking for something that's 2 or 3 bedrooms in this neighborhood. It should have XYZ. You're going to see the filters change. So the toggles on the filters are going to, like, as you type into it, it's going to say, oh, I gotcha. It's you want 2 or 3 bedrooms, and you'll see what you're searching for. So when it hits the search, it's also going to utilize the filters in a traditional kind of database search. So in that sense, I'm not super worried about the lack of recall. And likewise, you can start with the filters and you can say, okay, I'm going to set these filters. And then you can have you can use a chat box and say, oh, by the way, it needs to be like, it's super important to me that this is pet friendly. And it would be a nice to have if I were right within in these neighborhoods. And then it would rank your search results accordingly. Does that make sense?
Yeah, that makes sense. Thanks.
Other questions for Taka? Do we have any online? No. Great. All right. Well, let's thank Taka one more time.
Thank you.